बटन, लेकिन यहाँ लाइट नहीं है, मुझे पता नहीं इसका जो बैटरी है लैपटॉप की कब तक चलेगी, लेकिन जब तक चलेगी तब तक हम क्लास कंटिन्यू करेंगे। लेट्स होप पूरा घंटा निकल जाए। ओके, आई शेयर माय स्क्रीन। इसको करते हैं मिनिमाइज। तो लास्ट टाइम जो हमने किया था, हम लोग कुछ स्पेशल टाइप्स ऑफ सीक्वेंसेस को दिखाना चाहते थे, उनका लिमिट क्या है। मैंने वो एज थ्योरम किया था, उसमें पार्ट आई थिंक ABC हमने किया था कुछ क्या था वो, क्या था, ये था, हमने कुछ 3-4 पार्ट्स थे वो। लेट मी स्टार्ट डायरेक्टली। क्या था क्या, तो पहला ये था कि P is positive, then limit n approaches infinity. It was rather easy. 1 by n raised to power P is 0. And similarly, if P is positive, then the end limit as n approaches infinity, nth root of P is equal to 1. And this was P part. Then I had C kya tha? Limit n approaches infinity, nth root of n is also equal to 1. And D was if P is positive and alpha is any real number, then limit n approaches infinity, n raised to power alpha divided by 1 plus P raised to power n is equal to 0. And last but not the least was this: if modulus of x is less than 1, then limit n approaches infinity, x raised to power n is equal to 0. I think A and B हमने किए थे क्लास में, तो मैं C को प्रूव करता हूँ. That's the nth root of n as n approaches infinity is 1. So let's do it. So what we write is this. Clearly nth root of n जो है, it is bigger than 1. है ना? क्यों bigger than equal to 1 I should write, है ना? Why? Because अगर मैं इसको 1 देता हूँ, what would be that? To be 1th root of 1. वो क्या है? 1 है. अगर मैं लूँ square root of 2, that's 1.14. इसी तरह से cube root of 3, that also would be bigger than 1. तो ये सारे numbers जो है, this is always greater than equal to 1 for all n belonging to the set of natural numbers. So अगर मैं कहूँ let x sub n be equal to this root of n, nth root of n minus 1, this would be greater than equal to 0. Why? Because this is bigger than 1. So अगर मैं अब इस पे focus करूं and I apply binomial theorem to, then n would be, should I write it like this? Then 1 plus xn raised to power n would be the same as n. है ना? nth root of n का मतलब है n raised to power 1 by n. और अगर मैं इसको raised to power n करता हूँ, I put n. So इसको मैंने यहाँ लाया और फिर I raised both sides to the power n. Now I use binomial theorem, so this would be equal to, I think it would be 1, right? पहले 1 आएगा, फिर आएगा n times x raised to power xn plus, of course, n into n minus 1 by 2 xn square. इसी तरह से दूसरे binomial coefficients, और लास्ट पे आएगा I think x raised to power n. Right? तो मैंने इसको binomial expansion से expand किया. Nothing more than that. Now what I do, what I see that these are all non-negative quantities. Xn's are non-negative. So this is surely bigger than equal to this term. इस पे अगर मैं focus करूँ, that is n into n minus 1 by 2 xn square. In fact, this should be strictly bigger than this because, of course, it is 1. I take it strictly bigger than. Why? Because 1 तो बिल्कुल पॉजिटिव है, ये तो नॉन नेगेटिव है, of course, right? तो चूंकि सारे नॉन नेगेटिव है, ऐड करने से बड़ा ही होगा, मतलब this adding some terms that are non-negative should make it bigger. So from this I get n is bigger than n into n minus 1 by 2 into xn square, which implies that xn जो कि नॉन नेगेटिव है should be less than, इसको यहाँ flip करते हैं, so it would be 2 and n cancel, of course, 2 divided by n minus 1 under the square. Now this is of course true for all n bigger than equal to 2, क्योंकि 1 के लिए तो obvious है, हमें it is equal to 1, मतलब 1 के लिए undefined हो जाएगा, of course. So for all n bigger than equal to 2, this is true, and but we know for what is xn, for it's 0 when n is equal to 1. Okay, so this is what I have. अब इसकी मदद से मैं क्या करूंगा, if I let n approach infinity, so I have, चलो मैं फिर से लिखता हूँ, 0 is less than equal to this xn is less than equal to square root of 2 divided by n minus 1, and of course we have xn किसके बराबर है, xn is हमारे, हमने जो किया है, it is actually nth root of n minus 1. So that's our thing, and xn के लिए हमें ये inequality मिली. So what we do now, we just let n approach infinity. So letting n approach infinity, we see now letting n become very, very large, we see that this would become 0, right? So you would get a situation that xn is negative, but that would be a contradiction, है ना? So as n becomes very, very large, this becomes very, very small, infinitely small. So it cannot be positive. So therefore it must be 0. So letting n approach infinity, we see that ये जो इसका limit जो है 2 raised to power n minus 1 का, that goes to 0, which means that by squeeze principle या जो भी तुम कहो, so this is arbitrarily close to 0, therefore it cannot be positive, and therefore xn must be equal to 0 as n approaches infinity. So therefore limit, let me write it like this, n raised to power n, which is equal to 1 plus xn, therefore limit n approaches infinity, this thing is equal to limit n approaches infinity, this thing, और xn to 0 बन जाता है. I should write xn approaches. So therefore this would be 1 plus 0, and hence जो हमें चाहिए था कि nth root of जो है n as n approaches infinity should be nothing but 1. Right. Oh, next कौन सा था अपना d was this, जो हमें प्रूव करना है. d क्या था, d ये था x raised to power alpha divided by 1 plus p raised to power whole p raised to power n, मतलब इसका लिमिट जो है as n becomes very, very large, infinity is equal to 0, मतलब alpha is any real number. मैं लिख चुका हूं, तो इसको यहाँ हम इसको प्रूव करेंगे. So what I do, I binomially expand 1 plus p raised to power n. Now this would be equal to, I can just, तो you know that binomial expansion को हम ऐसे भी लिख सकते हैं, this is cn0 into 1 plus cn1 into x raised to power 1 plus cn2 into x, sorry, p how much is, so I have p raised to power 2 plus so on and so forth, cn n p raised to power n. This is just the binomial expansion जो हमने किया है. Now चूंकि ये p positive है, so this would be bigger than any of the terms. So I can take any arbitrary term, say c, and choose k, x raised power k. Now this is true for all k. So oh sorry, p है, p वहाँ मैंने x लिखा था इससे पहले. Now this is true for all k greater than equal to 0. है ना, क्योंकि हर कोई टर्म पॉजिटिव है, तो ये जो पूरा सम है, क्योंकि टर्म्स पॉजिटिव है, ये बिगर होगा each of, to be bigger than each of its terms. Now if I evaluate this, now this is the same as n factorial divided by k factorial into n minus k factorial whole multiplied by p raised power k. Right, but that can be written as n into n minus 1, so on and so forth, n minus k minus 1 divided by k factorial. मैंने इसको adjust किया, इसको division simple, nothing more than that, p raised power k, but this is bigger than n raised to power k divided by 2 raised to power k into k factorial into p raised power k. Okay, did I write it well? हाँ, ठीक है. Actually मैं यहाँ 2 raised power k ऊपर और नीचे दोनों लिख सकता हूँ. Should I write it like this? I've got n raised power k, p raised power k, 2 raised power k तो नहीं है, but this is correct, है ना? 2 raised power k में ऊपर और नीचे लिख सकता हूँ दोनों साइड पे. So this is what I have. I've got n raised to power k. Let me write it. ठीक है. Now why would be this greater? Because of course n minus 1 जो है, this is bigger than n raised to power k. Just a minute, मैं इसको ड्रॉप करता हूँ यहाँ थोड़ा सा बड़ा. Okay, I've got n into n minus 1 into n minus k. So this would be bigger than, कैसे? कुछ और भी था इसमें, मैंने कुछ मिस तो नहीं किया. I've got n raised to power k divided by 2. Oh. हाँ, तो मैं इसको डिवाइड करूंगा तब ये ग्रेटर देन बनेगा, राइट? ठीक है. So this is bigger than, what would be this bigger than? N is bigger than 2. I can write it as 2 raised power k, because n is bigger than 2 and minus 1 would be also bigger than 2. जितने भी मैं कर रहा हूँ, ये सारे numbers bigger than 2 होंगे. So it will be 2k divided by k factorial p raised power k. Now what I write is this. Now n0 is less than, because n raised to power alpha, n is a natural number, इसका real power है, positive होगा. So divided by 1 plus p raised to power n whole raised to power n would be less than 2 raised to power, नहीं, हाँ मैं k factorial लिख सकता हूँ, divided by 2 raised to power k, थोड़ा सा ये यहाँ ले गए, यहाँ ले गए, 1 by p raised to power k. I think this is what I should get. लेकिन ग्रेटर था तो चलो इसको देखते हैं यहाँ से. ये गड़बड़ है ना. 2 raised to power k divided by k factorial into p raised to power k is less than 1 plus p raised to power n, right? तो इसका मतलब क्या हुआ? क्या? Okay, it means that मुझे इसको डिनोमिनेटर में लाना है. 1 by p raised to power n is less than, इसको यहाँ लाएंगे, फिर ऊपर आएगा k factorial 2 raised to power k p raised to power k. That sounds okay. Right. ठीक है. Okay. Now साथ में आएगा of course n raised to power alpha. मुझे प्रूव क्या करना था यार? वो मैं कहाँ लिख गया? x raised to power alpha, this goes to 0 as n approaches infinity. So I've got n raised for alpha, right? ठीक है. और साथ में अगर इसमें मैं मिला लूं n raised for alpha, यहाँ हम एडजस्ट कर सकते हैं. हाँ, also यहाँ पर हम लिख सकते हैं also because n अगर greater than equal to 2 है, क्योंकि I'm letting it approach infinity. For n greater than 2, n raised to power k would be greater than 2 raised to power k. That means 1 by 2 raised to power k. 1 by 2 या यूं मैं कर सकता हूँ 1 by so 1 by n raised to power k, n is bigger than 2, n raised to power k would be bigger than, मतलब k is an integer, positive integer, is greater than 1 by 2 raised to power k. So what I do, so I can just write it like 2 raised to power k divided by n raised to power k is bigger than 1. So it means this is less than 2 raised to power k divided by n raised to power k into k factorial. ठीक है. Divided by 2 raised to power k pk. Reason ये है. So reason into n raised to power alpha. तो हमारा एक काम होगा, ये और ये हो जाएगा cancel. So what we get ultimately is this, यानी it implies that 0 is less than n raised to power alpha plus 1 by p raised to power n can be is less than k factorial divided by n raised to power k, k factorial divided by n raised to power k into n raised to power, of course p raised to power k भी है साथ में, और यहाँ बचेगा n raised to power, so it should be k factorial divided by p raised to power k, ये खत्म हो गया, n raised to power alpha minus k. Now alpha पे जो condition है, what is the condition on alpha is any real number, और अब जो alpha minus k है, k is an integer and alpha is any real number. तो अगर मैं इस पे फोकस करूं, यहाँ पर ड्रॉप करता हूँ, क्या हो रहा है इसमें आज? Okay, so it is k factorial divided by n alpha minus k ऊपर आ गया, so I've got k factorial divided by p raised to power k. Okay, for any fixed integer, this n alpha minus k would go to 0 as n becomes very, very large. So what we do is this. Since this is true for all k, all k means k is any natural number. So alpha जो है, alpha is some real number, so it would be less than some k. Now since alpha minus k is negative, because alpha would be less than k for some integer k, that would imply that क्योंकि मेरा जो n है बहुत बड़ा हो रहा है, तो इसका मतलब k का वैल्यू कुछ भी हो सकता है, k is less than equal to n, k is one of the values. तो इसका मतलब alpha minus k नेगेटिव होगा for large values of n. So that means ये जो ये नंबर है, इससे पहले हम कर चुके हैं कि n, so therefore n raised to power alpha minus k would approach to 0 by a as n approaches infinity. So which implies that अगर ये approach करेगा infinity को, तो बाकी जो है, ये जो ये नंबर है p तो कोई fixed positive number है. As n approaches infinity, this would go to 0 again by the same principle I must have, जो मैंने इससे पहले किया था. So therefore limit n approaches infinity, n raised to power alpha divided by 1 plus p raised to power n is equal to 0. अब है e part. तो e part क्या था? e part था अपना parts what is E part? E was this, right? मैंने पीछे लिखा था what was E? हाँ, E was just nothing but this modulus of x is less than 1. So E ये है कि mod x अगर less than 1 है, then x raised to power n limit as n approaches infinity is equal to zero. So this is what we have to do. So to prove the E part, now take alpha equal to 0. Okay, alpha can be any real number, alpha equal to 0 in t. So I get limit n approaches infinity. Anything raised to power 0 is equal to 1. I should have 1 by 1 plus p raised to power n is equal to 0, which can be written as actually limit n approaches infinity. 1 by 1 plus p raised to power n is equal to 0. So if p is positive, since p is positive, p is positive है, खत्म करते हैं. Since p is positive, if then mod of x जो कि less than 1 है, can be written as 1 by 1 plus p. Because you can write it like this. Why? Because modulus of x is less than 1. So p अगर positive है, तो this is also less than 1. So you can replace this 1 by 1 plus p by mod x, which implies that limit n approaches infinity. ये positive है, तो इसको x मैं मानूंगा. Positive है, तो इसको मैं I can just take it to be x. Positive means x या mod x same. So this is equal to 0. And we are done. By the same principle, so this would be like this. Okay, so ये खत्म हो गए ये parts. बीच में थोड़ा सा वो अटक गया था. So let's move to something more important. So these were some sequences, और अब sequences के बारे में हमें काफी information पता है. हमें पता है what is the limit point, what is the limit, what are the bounded sequences, what are limit superior, limit inferior, और हमें पता है limit superior is the largest limit point, and so on and so forth. ना वो जो properties हमने की है. Now we come to some general ideas about sequences. We also know what do we mean by the convergence of a sequence. So if you have a sequence an and runs from 1 to infinity, then we say an converges to some number L if ये बार मैं repeat करूंगा, for any epsilon positive there exists a positive integer n naught or a natural number n naught such that a n minus L in mod this distance is less than epsilon for all n bigger than equal to n. So this is the definition of the convergence. और हमें बहुत सारी चीजें पता है इसके बारे में, that it is unique वगैरह वगैरह. Now we come to what's called the Koshi's principle. Koshi's general principle of convergence. So let me write it down. Koshi's general principle of convergence. Of course, for real sequences. For sequences. एक general rule क्या है कि sequence कब converge करेगी? And I write it as a theorem, and this is a very important theorem. So what this theorem says that a necessary and sufficient condition, for the convergence of a sequence, is that मैंने sequence को लिखते हैं हम, चलो an as n goes from 1 to infinity of this sequence is that for any epsilon positive, there exists some n naught belonging to the set of natural numbers or positive integers such that modulus of am minus an is less than epsilon for all n bigger than equal to n naught. अब मैं इसको राइट और इसको जो कन्वर्जेंस की डेफिनेशन है अगर हम कंपेयर करें तो यहां हम कहते हैं इट कन्वर्जेस टू एल। कोई इसका लिमिट होगा, अगर लिमिट वी मस्ट नो फर्स्ट लिमिट, तो उसके बाद में ये डेफिनेशन अप्लाई कर सकता हूँ, है ना। यहाँ पर लिमिट का कोई कंडीशन है नहीं, है ना। इन दिस मतलब in this formulation of convergence there is no mention of the limit. It is about the terms of the sequence. am and an are terms of the sequence whose ये जो m और n है या जो इनका इंडेक्स है वो bigger than equal to some n naught है। तो this condition gives us the condition on convergence in terms of the sequences rather than मतलब इसके लिए हमें पहले लिमिट पता होना चाहिए, इसके लिए लिमिट पता होने की जरूरत नहीं। तो ये कह रहा है बेसिकली ये कंडीशन कि L के नेबरहुड में यानी जो टर्म्स ऑफ द सीक्वेंसेस हैं दे शुड एक्यूमुलेट अराउंड n। तो यहाँ पे ये कह रहा है कि टर्म्स ऑफ द सीक्वेंसेस शुड एक्यूमुलेट अमंग देमसेल्व्स। तो अगर वो अमंग देमसेल्व्स भी कन्वर्ज करती हैं तो वहां पे कोई L होगा जिसको वो कन्वर्ज करेगी। सो दिस इज व्हाट शो, और अगर वो कन्वर्ज करेगी अराउंड L तो दे मस्ट कन्वर्ज अमंग देमसेल्व्स आल्सो, मतलब एक्यूमुलेट अराउंड सॉर्ट ऑफ themselves. So it is in terms of the sequence rather than in terms of the limit. So that's the difference. तो हम कह रहे हैं कि ये कन्वर्ज करेगी अगर ये है, और अगर ये है तो ये कन्वर्ज करेगी। और इसी कंडीशन को कभी कभी हम ऐसे भी लिखते हैं, मतलब बात एक ही है, इसको हम ऐसे भी लिख सकते थे an plus p minus an is less than epsilon for all n greater than equal to n naught and p greater than equal to 1। क्योंकि अगर p greater than equal to 1 है, अगर n n naught से बड़ा है तो n plus p भी n naught से बड़ा होगा। क्योंकि ऑफ कोर्स क्योंकि हमें यहाँ कंडीशन क्या है, ये जो दोनों इंडिसेस है ये बिगर देन इक्वल टू n naught होनी चाहिए। अब अगर n को ही हम n naught से बिगर रखें और m की जगह लिखें n plus p, तो n plus p ऑटोमेटिकली बिगर देन n naught होगा। तो ये फॉर्मुलेशन भी सही है और बेटर है, कभी कभी ज्यादा काम आती है, क्योंकि यहाँ पे हमने एक ही को लिया दूसरे को उससे बड़ा कर दिया। ओके, सो मैं बार बार मतलब हम इसको प्रूव करेंगे हम कि अगर कन्वर्जेंट है तो ये कंडीशन ट्रू होनी चाहिए, और अगर ये कंडीशन ट्रू है तो सीक्वेंस कन्वर्ज करनी चाहिए। सो लेट्स डू दिस। सो प्रूफ, suppose that the sequence converges and let L be its limit। अगर कन्वर्ज करेगी तो इसका कोई लिमिट होना चाहिए। Then by definition, then for any epsilon positive there would exist an n naught, there exists an n naught belonging to the set of natural numbers such that modulus of an minus L is strictly less than epsilon for all n bigger than equal to n। अब ये definition obviously क्या बोल रहे हैं, मतलब for any epsilon positive, so I can actually write here epsilon by 2। वो इस वजह से है, what is epsilon? So epsilon is an arbitrary positive number। मैं इस पे हम बहुत बार इसको यूज करेंगे, इसलिए इस पे थोड़ा सोचना। तो if it is an arbitrary positive number, तो कोई भी positive number, तो उसका मतलब then this is मतलब as good as saying epsilon by 2, epsilon by 3 is an arbitrary positive number। रीजन वही है जो हमारा जो रियल लाइन है, इट कैन बी आर्बिट्रली स्ट्रेच्ड। तो मैं एप्सिलॉन की जगह एप्सिलॉन बाय 2 भी यूज कर सकता हूँ फॉर दिस पर मतलब आर्बिट्री पॉजिटिव नंबर. तो वंस आई हैव रिटन लाइक दिस, मतलब मैं इसको ऐसे भी लिख सकता हूँ, हेंस am minus L should also be less than epsilon by the same idea, but for all m bigger than or equal to n naught. Now I can write an minus am by the triangle inequality. I can write it as an minus L plus, no, I should write it plus an minus चाहिए plus L minus am. ठीक है, L will cancel. Now this is by triangle inequality should be less than or equal to an minus L plus L minus am. But this is the same thing as an minus L plus am minus L. And if I use this one equation, this is clearly less than epsilon by 2 plus epsilon by 2 for all n m bigger than or equal to n naught. So therefore, there exists an n naught belonging to the set of natural numbers such that an minus am is less than epsilon by 2 plus epsilon by 2 is epsilon. Now this is true for all n m bigger than or equal to n naught. Now this is precisely the definition that we wanted. यानी अगर सीक्वेंस कन्वर्ज करेगी तो ये कंडीशन ट्रू है. अब हमें इसका कन्वर्स दिखाना है. अगर ये कंडीशन ट्रू है तो सीक्वेंस कन्वर्ज करेगी. सो अब हम कन्वर्स इसका करेंगे. कन्वर्सली suppose that for any epsilon positive, there exists n naught belonging to the set of natural numbers such that modulus of a sub n minus a sub m is less than epsilon for all n m greater than or equal to n naught. अब हमें दिखाना है ये सीक्वेंस कन्वर्ज करे. ओके, सो हम क्या करेंगे? So we choose, so to make our case easier, we choose epsilon be equal to 1. Then we have, क्योंकि ये कोई भी positive number हो सकता है, so then there exists n naught belonging to the set of natural numbers such that an minus a sub m is less than 1 for all n m greater than or equal to n naught. Right? In particular, अगर मैं m की जगह n naught लूं, in particular, just to make our job easier, so I can write an minus a sub n naught is less than 1 for all n greater than or equal to n naught. क्योंकि मतलब m का वैल्यू क्या होना चाहिए? मतलब it is true whenever m is bigger than or equal to n naught. In particular, I chose m to be equal to n naught. तो तभी ये condition true होनी चाहिए. So this is what I get. So it implies that, जैसा कि हम इससे पहले कर चुके हैं, it means that an belongs to the open interval a sub n naught. Oh sorry, हम 1 मैंने लिया था epsilon, right? हालांकि कोई फर्क नहीं था. Yep. an naught minus 1, an naught plus 1 for all n, right, greater than equal to n naught. तो कहने का मतलब an के जो numbers हैं, right, जो n की जो terms हैं sequences की, after this stage must belong to this open interval. You can see where am I going ना, मतलब मैं दिखाना चाहता हूँ ये bounded है, मतलब इससे ये prove हो गया actually ये bounded sequence. So now if I take let G be equal to minimum of the set A1, A2, so on and so forth, an naught minus 1 उसके बाद ए एन नॉट ऑनवर्ड्स तो ये बाउंड है, तो मैं ए एन नॉट यहाँ ये +1 है, मतलब यहाँ इंडेक्स में माइनस है और यहाँ प्लस है उधर, राइट। और नहीं माइनस ही रखते हैं क्योंकि मिनिमम ले रहा हूँ मैं, राइट। तो ये -1 एंड अगर मैं जी लूँ, इससे पहले भी मैं ये डिस्कस कर चुका हूँ जब हमने दिखाया था एक कन्वर्जेंट सीक्वेंस इज बाउंडेड। तो यहाँ हम उसी आर्गुमेंट से दिखा रहे हैं जो एक जो कोशी सीक्वेंस है वो भी बाउंडेड होती है। तो ये इजी है प्रूव करना, लाइक द सेम वे। सो देन आई कैन से, अगर मैंने ये लिया क्योंकि मैंने ये सबसे बड़ा लिया इनमें से और ये सबसे छोटा, इट implies that an is bigger than equal to g and less than equal to g for all n belonging to the set of natural numbers, which implies that the sequence an is bounded. Every Cauchy sequence is bounded. और हम तो ये दिखाने वाले हैं कि ये कन्वर्ज करेगी। अभी <1 मिनट रहा है, ठीक है। चलो हम इसको यहाँ बंद करते हैं। सो अब